No, you're
So part 2 says a study of National Association of Realtors reported in 2004 that the second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. A real estate agent wants to estimate the average age of those buying investment properties in his area. He randomly selects 15 of his clients who purchased an investment property and obtains the data shown. What are the requirements for creating a 95% confidence T interval? I remember reading that. I think it's a random sample of the population, and the sample statistic will be normally distributed, or the sample mean will be normally distributed, because it is a large sample size.
Mm-hmm. Yeah. Okay. With the data above, create a 95% confidence interval to estimate the mean age of all clients who buy an investment property. Input the numbers you computed in number 7 of part 1 into the confidence interval formula. Show your work below. The t-score for a 95% confidence interval from the t-distribution with 14 degrees of freedom is 2.1448. Round your upper and lower bound to 1 decimal place, but do not do this rounding until you have done all your computations.
Let me grab my calculator.
You said 95%, it's the 1.96, right?
Yes. So the sample mean is 46.73.
Mm-hmm.
You subtract
1.96.
My charges are very in my backpack. I know it's divided by the square root of 15, right?
Yeah, it should be.
But then how do you find the standard deviation again?
The sample standard deviation.
Mm-hmm. Is it that formula T equals the sample mean? That one.
I don't think so. Um, I think it's just from. Can you go to that table on some of the numbers real quick?
27. 49.
Okay.
56. 45. 49. 35. 55. 50. 46. 48. 48.
Okay.
51.
All of them.
Only 19. Oh, never mind.
Okay, yeah, I was just making sure I was there. So when you put those numbers in the Excel, the sample t-test for sample means, or for means, it gives you the sample mean and then the standard deviation in there.
Okay.
So that's the 46.73, and the sample standard deviation is 8.83.
Okay.
The Excel t-test. But I thought I did the formula right, and I got a different number than the answer key had. Oh, I think I know what I did wrong.
Okay, for the lower bound, I got 42.261.
That's what I had, but the answer key says 41.8.
Yeah.
I'm trying something else real quick. This. 42. So are we putting in the wrong number for the t interval?
Mm-hmm.
Back to the reading. So I think we were putting in 1.96, but I think we gotta find. That doesn't make sense though, because it says to put we have to find the t-value, which is the sample mean minus the mean, so it'd be 47.63, right?
Mm.
Minus 47, and then divide that by 8.83 divided by the square root of 15. Oh, maybe that is right. I got a different number this time. Okay, keep this. Keep this. Put this number in. 0.27632837. Yeah. Okay. Now, so what I did is I'm going to see if this is right, but there's that formula to find the how does it word it? For the one sample t confidence interval.
Mm-hmm.
And then it says when conducting a hypothesis test for single mean with sigma unknown, the formula is t equals, and it has the sample mean minus the mean divided by the sample standard deviation divided by n, the square root of n. And in the reading, it was saying how finding the confidence interval is very similar to the formula when you know the standard deviation to when it is not known. Instead of using the z-score, we use the t interval. So 47.63 minus, what was that number? 276.32837 times 8.83 divided by t. I don't think so. That didn't give me the right answer either. Oh, I think it 47 points. What's that formula again? Times 8.83.
What number is the mu again?
That's the mean. So for this one, it'd be 47.
Okay. And then the x with the bar on top is the sample mean?
Yeah.
Mm-hmm.
So is 2.1448, is that the number we put in for the t-score?
I think so.
Yeah. Well, I put it in and I got 28.
You got 28?
Yeah.
Let me see.
So 47.63 minus 2.1448 times 8.83 divided by the square root of 15.
So it's closer, it's still off. Isn't 99% of 1.96? Do we have that wrong?
No, it is 1.96, but look at, what is this then? This is the t-score, not usually the z-score.
I didn't see that. You're just so close, that's what I'm wondering.
I typed in 1.96, that's wrong too. What are we not getting?
No.
Okay, so on SPSS, is there a T interval?
Oh. I don't know how you, on the Excel, that Excel one sample t-tests, it gives you the answer right there.
That's what
Okay.
But it says to round it, and I don't know, there's got to be a way to calculate it. It says show your work below, so
I think she just means like plugging it in. I don't know if there's a way to calculate it without like a program though.
What? No.
oh, we're chucking
That's
stuff.
what I said, because I said, oh, it shows you the answer, because I saw it. So then try doing number 3. Because it's 9 instead, and it's 2.9 for the degrees of freedom. Huh?
You can do it. You can do it too.
Well, I keep doing the wrong equation. I don't know what I've got going on there. Because you're so close, even on there. Do this. So that's why I'm wondering if you really can't calculate.
I hate you. Because yours says SPSS. Mine doesn't. How do I even find SPSS?
What?
So how do I even find
Use your 3
SPSS?
fingers like this. The full menu bar.
Yeah?
And then for SPS is an app. It's just like an iPhone.
Okay, look, it's there. You'll need to conduct the analysis of the software so you can report this out.
Yes.
You have to use the software to report it out.
Just get the app.
If I'm wrong, I don't know. I could be reading it. I don't know, like,
Well, how do you get 99% confidence interval? Oh, it's right there. I don't know. Maybe you were. I put in that formula that it has above on number. No, it's number 4. On number 3, excuse me. And my numbers are really close, but they're just a little bit off.
Yeah.
But
That's what keeps happening to me. So I'm trying to open up SPSS.
there was that Excel thing that they had on there too. That Excel, it has the page for one sample t-test for means. And I put those numbers in the variable, and then you can change the confidence interval, and it gives you the confidence interval for what it is. And I changed it for 39, or excuse me, for 99 and for 95, and the answer was right for both of them.
Okay.
So maybe that's what you do. I don't know.
see, that's confusing because then in number 4, it tells you to use the software. And you get the same answers.
So yeah, there's that form,
There should be.
and it's number 3, but I don't understand what we're putting in wrong.
I'm so confused.
Oh, you gotta understand it before you keep.
I know that. I do
It helps if you read it before, then you can get through it easier. I don't really know how to sign it. My fault too. Under. What happens if you. Oh my gosh. But I just got it.
You did?
I must have been typing in a wrong number or something.
Did you have to do it on the Excel or?
No, it's for the 99%. For the 99%, you take 46.73. I must have been putting in 47.73 or something. But you take 46.73, which is that the mean we got up on number 7.
The sample mean?
Where am I? So 46.73 minus, and then the Z gives you that t-score of 2.9768 times 8.83 divided by the square root of 15. And it gives you 39.9.
Okay. Woo!
I must have just been putting in the wrong number or something.
Don't you just love that?
That's
on
the one thing. That's the one thing about stats that drives me, or math that drives me nuts.
I know. Like I have all of the right steps, just that one number.
So then it,
Scroll up to the chart so we can put this in.
Okay, I got 53.5. The next one.
yeah.
You're a genius, Chase.
I don't know about that.
Okay.
So then we put it in the software,
Mm-hmm.
and that gives you the same numbers.
Yeah. How does the margin of error of the 95% confidence interval compare to the 99% interval?
Should be smaller.
It's smaller, yeah.
As it gets bigger, the amount of error gets smaller.
We're on the last question, but it has like 5
A
parts.
million parts. Okay.
Rather than estimating the age of his clients that buy investment properties, the realtor agent would like to test the claim that the age of his clients is different than the national average age of 47. Use the 0.05 as your level of significance. Follow the following sequence of steps. Fill in your answers at each step and show all your work.
Great. Oh.
Okay, so the null and alternative hypothesis.
Okay, so the null is that it's equal to 47,
Yeah.
and he's checking to see that it is just different. So the alternative is that it is not equal to 47.
Compute the test statistic. First, compute it using the formula and showing your work below. Then check this test statistic by inputting the data into the software.
Okay, so the statistic is t equals sample mean minus the mean divided by sample standard deviation divided by square root of n. So it would be 46.73 minus 47 divided by 8.83 divided by the square root of 15. And that gives you
0.118.
Negative.
Negative. State the degrees of freedom. So it would be the 15 minus 1.
Yeah. So that'd be 14.
Sketch the t-distribution and shade the area which represents the p-value. Okay.
Um,
I don't even know what to sketch. That's my drawing.
oh, I want to see this. Hold on.
That's nice.
Oh, that looks good.
Looks great.
Yeah. I don't even know what to sketch.
I'm trying to look at the other sketch on the.
He's an idiot.
What's that?
This kid, our dog's an idiot.
Hey.
I don't know, in the reading, it has that little kind of like that. It's more bell-shaped because the degrees of freedom are close to 15, as it shows in that. Yeah, I don't know how to sketch that.
Me neither. Let's see.
I think your sketch is gonna work perfect.
Yeah, I think it
No, right?
will be just fine.
I think it's just kind of like the sketch of like the shaded area, like when we were trying to compute the probabilities.
Should we go to the next one?
Yeah.
All right. Use the software to compute the p-value. Oh, great. Now the internet's all wigging out to try to click on that t-distribution thing.
That's my belt. I'm just going into our room.
Hey.
Do you guys know how to do that? Because I don't.
Trying to remember. And this one had so many different SPSSs and all that stuff.
Do you do the? Don't you can? Oh wait, it's right here. Isn't that it?
No, what were you gonna need? That's
No.
given in the software. That was really the problem. See, the p-value it gives in the software is not at all like it says in there.
Mm-hmm.
Because one of the software, according to this, is 7.67234 times 10 to the negative 12.
Yeah.
Well, that's not right. Well, F and G are really easy.
Yeah.
We can just figure out this little guy.
Well, I mean, we know the p-value is 0.9077.
But
Can't remember how we got that.
So if we look back into the reading, body temperature one, oh,
Your dad just told me about Chase's shoulder. Just wondering how bad it was. I didn't know if she'd be at the hospital with him or if he's in surgery or what. He can't answer. Go ahead and shoot me a text. I know how hospital life can be. She seems very concerned. And I'll also
I have no idea how to do this. This one.
I don't know either. But if you do an SPSS, like if you enter in the information for the t-test, it says that it pulls up like the p-value and everything, but I just don't know how to do that.
See, I got it in Excel, so let's try. If we just put, can you type those numbers in manual on SPSS?
I guess. I'm still having trouble pulling up SPSS.
Is there a file in SPSS? On this thing?
Give me the numbers.
I have same ones? Right here.
No.
45, 49, 35, 55, 50, 46, 48, 39, 51, 56.
Okay. So I
Is that
haven't.
right there? Oh, tree. Sorry, it just says T-test right there.
I know. So I even put those numbers in SPSS too. I have no idea where they're getting that p-value from.
I don't know either. I just like Googled how to do it manually. But that's not helping.
Did you find something?
Well, yeah, it came up and it like showed me this like big chart of like, oh, if you have 0.05 significance and this many degrees of freedom, it'll equal this. But there isn't like anything for.
Forget that.
Hold the phone.
Trying to calculate.
P-value.
Can you do SPSS?
I don't know how. I can't even open SPSS.
What is that though?
What is
It's
what?
right here.
That's
No.
the P. That's the p-value.
I know, but it required a password and I didn't know a password.
Well, it's just you be Idaho account. Because it's your remote, it's access.
I know, but I came up with Chris Pearson. I don't know your username because I got sidetracked.
Same things in
Hold on.
No PDF. I don't even know what I'm putting in there.
Where's, give you, is this the worksheet that you worked on?
No.
Where's the worksheet that you done? This one?
What are you asking me again?
That chart, it's like this. And it shows the p-value up here and the x squared.
Oh, but
What's that?
I don't know what I'm
What is it? Remember, p-value is up here. It's called.
That's the z-square. That's the area.
I know, but can we put the c-square in there to find the p-value? Because it shows what the p-value is, doesn't it? Doesn't this show you what the z-score is?
this is the quiz, it's just the homework.
Alright.
What's the z-score?
Yeah, I never heard of that.
That chart?
I always used SPSS.
Hold on.
Can't do things more.
But what are we gonna put in though? Where's
Where's the 8? You don't have to back.
where's the z-score in here?
27, 49, 56,
Isn't it used to show?
49, and the next row is 35, 55, 50, 46, 48. And then the next one's 38, 58, 51, 56, 38. It's not gonna work.
Shut up.
I can't remember.
I'm baffled right now.
Intimidating. All of them.
It tells you in that worksheet.
No, it doesn't. I can do it. I can do it.
So, back on that problem about talking about body temperatures, it tells you kind of what the p-value is. It says, how do we use the sig two-tailed output to find the p-value? This depends on the alternative hypothesis. Consider each of the following alternative hypotheses that could be used in a test for a single mean where the null hypothesis is u equals 98.6. And then it lists it's either greater than, less than, or not equal to. And so we click on the one that says not equal to, and I did that in the Excel, so it's not equal to. But I'm still, I don't. Oh, maybe if I do this.
Oh, I'm sorry. The p-value's right there.
Okay. I put it into SPSS and it's not pulling up a p-value.
I know, that's what in the document it says that the sig two-tailed. So in SPSS, it gives you that sig two-tailed, but the thing is, it says 0.000.
Yeah.
And that means that it's really small, but the z-score that the answer is 0.9, and that's not very small. Or the p-value, yeah.
Yeah.
And then in Excel, it gives you 7.67234 times 10 to the negative 12. That's really small.
Yeah.
So I am super confused.
Yeah, me too.
Like it gives you two different answers.
Ah, got it.
You did.
So if you use the one sample t-test page again in Excel, it gives you variable 1. I didn't know we could play with that and not mess it up, but it gave you the t-score, and the t-score was like 20-something. But I went back and put the number in that we got when we did it earlier in the worksheet.
Yeah.
Negative 0.118, and that's where I got the 0.907.
Oh, good.
Jeez, Chase.
So then we failed to reject it because it's greater than 0.05, and we don't have enough evidence to say that the mean age of the realtor's customers is different than the nation's or average.
Yeah. Can we just talk about how it says present your conclusion in an English sentence?
Yeah. Can I not write it in Spanish? Gosh.
Okay, are you ready for the quiz?
We are ready.
As ready as we can get. Okay, are you there?
Yep.
Okay. In previous lessons, we have assumed the population standard deviation was known. In this lesson, we are making a different assumption about sigma. What has changed?
We assume it is unknown.
Yeah.
Number 4, the null hypothesis is the mean equals 8. The alternative hypothesis is u is greater than 8, and the population standard deviation is not known. Becca collects a sample of 9 and computes the sample mean at 11 and the sample standard deviation at 6. Use this information for questions 4 through 5. Is the standard deviation known?
No.
No.
What is the value of t? I don't.
On number 4, do you think it's? You don't think that's a trick question, do you? Because I know the standard deviation isn't known, but do you think standard deviation is not always equal to the sample standard deviation, right?
Correct. I don't think it's a trick question. Maybe she just feel bad for us.
So to get the t value, we go back to that formula. 11 minus 8 divided by 6 divided by the square root of 9.
Was it 1.5?
That's what I got. Read that.
Yeah. Use the following values which were pulled from the data file body temp. Copy and paste them into the software you are assigned to use. Using the null hypothesis of 98.6 and alternative hypothesis of 98.6, and level of significance is 0.05. Just think it'll let you copy and paste it, or do you want to just have it watched? Is it the inference procedures?
That's this one. Okay. That t-score is 1.5. Don't mess that up. Okay, did you put that in there?
Yeah. For the mean, I got 98.22.
Yep.
$220, right?
Are
Yeah.
you putting in 98.220?
Yeah.
Okay. The S should be 0.922.
Yeah.
And the t-score is
That's a big number.
what did you get for the t-score?
Mine says 476.407.
Mine when I put those numbers in, it left. Yeah, when I put that in, it doesn't change the T-score. So
it'd be 476.
see, what was your T-score?
Mine was 476.407.
Oh gosh, I don't even know.
That's weird. I wonder why mine doesn't do that.
What do you have?
It just doesn't correct
It does. Yeah, it doesn't do anything.
Hmm.
I wonder if I messed it up when I put in at 1.5. I wonder if I messed it up one time. Let me.
See if I'm getting the same thing.
I must. Yeah, I must
Put
have messed it up.
this is 0 and see what you get.
Yeah, I must have messed it up.
Oh, it still doesn't change it.
Yeah. If you take the formula out of there, then it messes it up. All right. What is the p-value?
I don't.
0.907.
Wrong number, remember?
No. Just
Did you
kidding.
get? Wait, that's a really small number though.
What does your p-value say?
I don't have one.
Did you put it in SPSS?
Yeah.
I don't have it in SPSS though. Which one is it? Yeah, what? Strega?
Yeah.
And where do I go?
Analyze. Compare means. Up. Down.
Independent?
Up. Right there.
Why don't you say the one sample?
I don't know.
Here it is.
I've got it too.
Oh, I thought you even had the right data.
I do.
It's a little longish.
It looks like we reject the null hypothesis because the number is really small.
Mm-hmm.
Go back to Excel. In Cambria's Excel, it has the p-value is 0.16647 times
1.66.
times 10 to the negative 40th. So that's super small.
Mm-hmm.
So if we round that number, it's going to, and our SPSS it just showed 0.00. So is that the answer?
I'm sorry, what?
Because in Cambria's Excel, it has the number as like 1.6 something times 10 to the negative 40th.
Mm-hmm.
Same thing. No, it's not times negative. It's times 10 to the negative 40. It's not just negative 40, it's the 40th.
Whatever.
And then in the SPSS, it says in the reading that if you double click on the .00, it'll give you more digits. But even then, all it gives you is .00.
Yeah.
So I don't know. I don't know if she wants us to yeah, I think it's just going to be .00. If we get it wrong, then we get
I'm
it
okay.
wrong. Use the following values which were pulled from the data file Baby Boom. These values are the wait time in minutes between births at a hospital. Copy and paste them into the software you are assigned to use. The hospital claims that the average time between births is 40 minutes and plans its resource allocation based on this claim. You want to test their claim. You select the null hypothesis as the mean equals 40.
Okay, my p-value says 3.0842 times 10. But you looked at it last time on the other. Let me put it in SPSS.
This p-value stuff is giving me a headache.
I think it's stupid and we won't ever use it. First alternative. So for the p-value on here, I got the 0.000062.
Yeah. So even if we round the nearest three decimal places, it's still
Still at
0.00.
Mm-hmm.
That's why it's frustrating. I don't understand.
Like, what's the point?
Yeah. Then that would be fail to reject.
No, we would reject
Right,
it.
yeah, reject it.
Okay.
Just like the one above. Okay, you decide to try another alternative hypothesis. This time you use 40, and you keep the same
It's
level.
less than 40.
And you keep the level of significance. Did the p-value increase or decrease?
Let's go back to your Excel. And then right here in this tab, select less than. The p-value increased,
Okay.
and then we failed to reject it because it was like 0.99 something.
Compare the width of the confidence interval for question 11 to the confidence interval of question 13. Which one is wider?
Wouldn't 11?
Equal to 40 and less than 40? Because if it's less than 40, it's going to be smaller. If it's greater than 40, or equal to 40, then it'll be wider, right?
I have no idea.
So 11 would be wider. Did you say 11?
Yeah.
I would think.
I'm not sure how to do this one. I honestly can't remember. So
I'll submit. Just see what we did. Better get that one. Yikes. Go ahead and click there the same. And decrease instead of increase.
no, it's increase.
No. Oh. So you had it right. No, decrease. And fail to reject.
So wait, what?
So,
Go down, go down, go down. I'm not understanding this p-value stuff.
Me neither.
Go back to your Excel thing. And then type, put in there, not equal to. Hold on a second. So, the sampling mean. Sampling mean is 40.048 minus 40. Divided by this 656 divided by okay, no. 0.006. Ah. I get it. So when you put it in Excel, you've got to put in your T-score manually.
Oh, okay.
Megan, have you submitted it yet?
Not yet.
Okay, Chase has lots of new stuff for you. So don't do it yet.
Okay.
Wigging out. Um,
Go ahead, Dean, please.
Can you get some water? Thank you.
I'm a better father.
okay. Um, Okay, so I went back up to the top
Mm-hmm.
to number 6. So I mean not 6, excuse me, 8. The T-score for that one is negative 1.843.
Okay.
If you do the calculations on it, I think that's what the answer is. So that would make the p-value, as you put that in the Excel, if you put less than, it'd be 0.040. And again, we would reject the null. So we've got that one right. And then, let's see. Number 11.
Mm-hmm. The p-value is 0.995. Okay.
And so 12 means you'd fail to reject it. And then when you change it to less than, it goes down to like 0.5 something. So it decreases, but you still fail to reject it. And then 15, I think, is that they are the same.
Okay.
So that's what I think. And it's right.
Woo! Good work.
So just remember, you to get the p-value, you got to put in a manual t-score.
Okay.
All right.
Okay, I'll see you next week.
Sounds good. Have a good weekend.
You too. Bye.